So sums of random variables is one thing that is very important in statistics. The other would be quotient, division of two random variables. They come often in advanced data. And oftentimes, if we have a bunch of known distributions, known in the sense Bernoulli is a known distribution, added a bunch of them, I got binomial. I could add a bunch of binomials together also. But I can only do this under few conditions. Condition number one. Well, I'll write the condition for a second. Suppose x is binomial n1 comma p and y is binomial n2 comma p. That would imply x plus y is binomial n1 plus n2 comma p. Can you notice?
Equal chance of occurrence.
So the probabilities are the same. They have to be. So otherwise this is not going to hold true. So x and y must have the same probability of success. Second, x comma y are independent. Random variables. RVs doesn't mean recreational vehicle, a random variable. So they are independent, but they're not identical because n1, n2, right? So independent, but they're not identical. We'll call this W equals x plus y. So we want to find the distribution of W equals K. Yes. Now, W equals K could be written in a way based on what we did earlier. What is the next step? What did we do next? And then to proceed further, we had to do something. What did we do? Huh? Partition and use, what is that law, Nathan? Law of total probability. So probability W equals K. I want to sum over all possible values for y, right? If you go back and look at our previous problem, I conditioned on n, on that variable y, and I looked for all possible values for y. So I want to look at all possible values for y, and what are they? 0, 2, and 2. So I can write this as probability x is equal to k minus y, given y equals I, multiplied by probability y is equal to I. Good. So again, some people like to keep that conditioning till the very end because conditioning is not division, it's not any operation, it's just indicating that I'm going to apply value I. I'm going to get rid of it because I'm lazy. X is equal to k minus I, multiplied by probability y is equal to I. This is what I want you to do. I want you to take the PMF, plug in the value here, plug in the value there, and see if it simplifies. X is binomial n1 comma p. So I can write it as n1, choose x, k minus I, p raise x, k minus I, multiplied by 1 minus p raise n minus k. In this case, excuse me, n minus x. In this case, n is n1 for random variable x, so we would have n1 minus k plus I. So the other one is easy. We could simply write it as n2, choose I, p raised I, q raised, keep going, q. Q. So typically 1 minus p is always q. So which is why my mind keeps on going for q. I don't know what your book uses. Yeah, we should probably stick with p's and q's. Now, could I simplify it in some way?
Yeah, excellent. But you simply, I don't know.
So p raised k minus I, p raised I, that will simply give me p raised k. And over there, I'll have 1 minus p, n1 minus k plus I, plus n2 minus I. And I'll have n1 plus n2 minus k multiplied by n2 I. So I can pull those two terms out. Do we understand why I'm able to pull those two terms out? The p raised k and 1 minus p raised n1 plus n2 minus k. They don't have i's in them. Since they don't have ice in them, they are probably warm. Warm.
Ice or ice?
It's a bad joke.
That's awful.
Okay, where do we go from there? I'm going to erase this part. that doesn't look anything like binomial, right? We got part of it, right? Typical p raised k matches. 1 minus p raised n minus k over here, that matches. But then I've got that sum. That doesn't look like n choose anything. How can we simplify that? Do the exponential stuff.
Do not exponential factorial.
You don't have to. I don't know how they pronounce his name. It's either Van der Monde, like French, or Van der Monde. So I've heard people say it as Van der Monde more often than Van der Monde. So the identity states that I could take this part and write it this way. You could sure do the factorials and stuff also, but that's Van der Monde's identity. So it would reduce to n1 plus n2. Yes.
So does that include the whole sum part in that new choose function?
Yes, the sum is important. We need that sum.
Okay, but it gets converted into
This.
function. Okay, so don't use it again.
Yeah.
Okay.
So all of this would result in that. So we conclude probability W equals K is P raised K, 1 minus P raised N1 plus N2 minus K, multiplied by N1 plus N2 choose K. Yes. So the probability of success becomes P. The number of trials is N1 plus N2. And the trials are independent of each other because we've already concluded that X and Y are independent variables. So this would mean that W is binomial N1 plus N2, comma. Take a guess. If I had a whole bunch of binomials added together, as long as I have P, what do you think the final result will be? It's simply the sum of the sample sizes. So for instance, if I had x1 to be binomial n1 comma p, x2 binomial n2 comma p, x3 binomial n3 comma p, if you sum them together, the result would be binomial n1 plus n2 plus n3 comma p, as long as the random variables are independent and the probabilities are the same. Are we clear? Yes. Okay. Well, so we have 150 patients from county A and 50 patients from county B. They are admitted to a hospital, Hospital A and Hospital of Death for surgery. Now, both hospitals have a success rate of 80%, just like last time. The question is the probability that 60 patients would die in Hospital A greater than the probability that 60 patients die when you combine both hospitals. Good? Does that make sense? Now, even before we start the problem, from a practical standpoint, could we make the assumption that we have two random variables and they are independent? Nathan says yes. Why?
Because one hospital is like over here, another one's like over here. They're not affecting each other.
Okay, but we're talking about the patients too, right? We're talking about the patients also.
Well, I mean, I imagine that you're not gonna have like one patient, like the patients are coming from one county and another county, they're separate counties.
So we can claim or make an assumption easily that they are independent because these 150 patients come from county A, 50 patients come from county B. So how to model this problem? The success event here is that the patient dies after surgery. Very morbid, but you can follow. So X1 can be modeled as a binomial. Agreed. And what is N? 150. The probability of success is 0.8. X2 is binomial. What is N? 50. Now, what do we need to answer that question? Come again. So we want to add and define a new variable. So W would be X1 plus X2. And combined number of patients from hospital 1 and hospital 2. So both counties merge into one hospital, but independence is due to the fact that they come from different counties. Good. We need to find the probability X1 is 60. X1 is simply the number of people who die after surgery.
Shouldn't it be 0.2 for the probabilities? No, the success rate.
Yeah.
Die. It's X1 higher.
It's 0.2, thank you. Or not to confuse, we can call it successful surgery, right? And that would change this.
It would change it to 0.2.
Well, it changed to 0.2. So X1 is the number of people who die in hospital A. X2 is the number of people who die in the hospital of death.
Oh, so 50% so that 150% hospital.
So the probability that they die is 0.2. So I'm defining the success event to be dying at the hospital. So how do we find probability of X1 equals 60? Don't plug it in your calculator. Did I show you Binomial PDF last time? So let's use the calculator Binomial PDF. So binomial PDF, N is 150. Point 2, X is 60. And what is that?
1.0108 is from standardized state.
The second case, probability, what are we trying to find? W equals 60. What is N? N is 200. P, same. The reason being, when you add two independent binomials, the resulting random variable is binomial, but you add the sample sizes, 200, provided you have the same success probability. And what is that number?
Two 2.1979 times 10 to the minus 4.
So what we're suggesting is the probability that 60 patients would die in hospital A is it greater than the probability that 60 patients would die combining both hospitals? It turns out that is not true, right? So this probability is bigger than that probability, but does it make sense? Huh? Huh? Does it make sense?